Good morning, everybody. We are going to keep moving through the very last section of Chapter 5 today. So a pretty interesting thing. I hope you had a good time on Tuesday when we were together, kind of comparing the sizes of angles in a triangle, kind of help you understand the sizes of the sides and the sizes of the sides or length of the sides, kind of help you understand the relative length of the angles. And so now what we're going to do is we're going to do the exact same thing, but we're going to compare it in different triangles. So as you can see in this picture right here, and if you haven't yet, I want you to get something out with which you can write and something on which you can write. And so I want you to look at this picture. All right. And in this picture, I want you to try to go ahead and draw something very similar. In this picture, you can see that this side right here is the same length as this side and the same length as this side in these three separate triangles. And that this side right here is the same length as this side right here and the same length as this side right here in these three separate triangles. And clearly, you can see that the one thing that is different is the size of that included angle. In the first one, it's 45 degrees, and the next one, it's 75 degrees, and in the last one, it's 90 degrees. And our job is to look and see how does that affect this other side that I've colored green. You know, how is X different from Y and different from Z? And what we can see is even if we hold those sides that I highlighted, even if we hold those consistent in size, as we open that angle, clearly that opposite side, opposite of the angle, gets bigger, okay? And so as we change the triangle, as we open up that angle, that opposite side gets bigger. This is called the hinge theorem in your book. It says if two sides of one triangle, you know, here's one side and another side. If two sides of one triangle are congruent to two sides of another triangle, then the third side is going to be bigger in the one with the bigger included angle. And that sounds like a lot of words, and that seems kind of hard, so I thought I'd try to give you a drawing to best represent it. And so that's what we're looking at right here. Now, let me give you an example about how we could kind of apply this. So here's another situation. We've got these two triangles, triangle ABC and triangle DEF. And we can see, again, this side right here, side AB is the same length as side DE. And also, side AC is the same length as side DF. But because this is a 91 degree angle and this is a 120 degree angle, well, then it's clear that the side BC would be less than the length of side EF. Okay? And it's that simple. Just like in this first picture, we would know that the length of X would be less than the length of Y, which would be less than the length of Z. Okay, and that's the same thing going on here because we can see that angle opened up to be larger here. So that would make this side, the side EF, to be bigger. And so we can write an inequality just like this. All right, and now we can do that even, it can have some algebraic expressions in it. And we'd still write the inequality and we can still simplify and solve it in a situation that looks like this. Here's virtually the identical situation. And a second ago, we said because this 91 degrees is bigger than the 120, then we knew that the length of BC would be less than the length of EF. So therefore, 2x plus 4 would be less than 4x minus 2. Okay? And so you could solve that. And you could say, well, we could subtract 2x from both sides. And that would leave us with 4 is less than 2x minus 2. We could add 2 to both sides, and we would get 6 is less than 2x. And we could divide both sides by 2. And we would get that 3 is less than x. And another way to say that would be that x is greater than 3. That's the same thing, saying 3 is less than x and saying x is greater than 3. So when you look at this situation, one thing that we would know, we don't know the exact value of x, but we know that x has to be bigger than 3 for this situation to be true. Now, that was a lot of algebra really fast, and I'm sorry if that kind of hit you quickly, but what you can see clearly is that when we have two congruent sides, this side's congruent to this one, and this side's congruent to this one, the third side will be biggest when the included angle is the biggest, okay? And so therefore, we can write an inequality. And we might not be able to find out what x is or what some other angle is, but we know its relative relationship with something else. All right, now that you've seen a couple chances, now it's time for your turn. So here we go. Very similar to what we just did, I want you to try to solve for the possible values of x. So we're going to pause the video for just a minute as you work on this one. It'll probably take you about 2 minutes at the most. So you don't have to draw the pictures if you can kind of come up with what you need to do on your own, but you're welcome to draw the pictures. We can pause the video right now and I'll come right back. Okay, and we're back. Let's see here. So in this picture, I know that this side right here has to be smaller than this side right here. And the reason is because I can see this is the same length as this, and this one right here is the same length as this one right here, but this is a larger included angle than this one right here. And so then that would mean that 5x minus 7 has to be less than 23. And then my job is to solve that inequality. And so I solved that by adding 7 to both sides. So I add 7 here and add 7 here. That gives me 5x is less than 30. And then I divide both sides by 5. And I get that x is less than 6. And that's my answer. It says, what are the possible values of x? Well, I don't know what x is, but x has to be less than 6. As long as x is less than 6, this situation will be true. Okay, hopefully you got that one right. It's pretty simple. Now, it's not x equals 6. It's x is less than 6. We're finding a relative value. All right? Okay, let's try this next one. These are going to get a little bit more complicated as they go in the pictures. Okay, and so now your turn number 2, we're going to look at this one right here. Now, believe it or not, this one has 3 different sides that we can kind of find a relative length, AB, BC, and CD. We can see that these 3 angles back up to each other so as to create a straight line, okay? So we know there's something special about these angles right here. They all back up to each other so as to create a straight line or straight angle. So we know they must add up to be 180. So we could find this unknown angle right here. All right, and so you can do that. You can see we've got some congruent sides, and your job is to find find the relative sizes so that you can order A, B, B, C, and C, D from the least to the greatest. Okay, this shouldn't be too hard. Again, this should be about a 2-minute problem. So I'm going to give you 2 minutes. We're going to pause the video right now, and then we'll come back and take a look at it. Okay, well, let's take a look at this. The very first thing you have to do to solve this problem is you got to find out what that other angle is. So I know, I'm going to call it x. So I know that 62 degrees plus x plus 46 all must add up to be 180 degrees. Well, 62 and 46 is 108, and plus x must equal 180. So I subtract the 108 from both sides, and x would have to equal 72. Now, that might not be accurate in my picture. My picture might not be very accurate, but I'm saying, well, this would have to be 72 degrees. Now, I don't know if you guys can see all that we have going on in this. Let's see. I'm going to try to get rid of a little bit too much. I'm going to see if I can help make this make sense. Okay, but what we can see is that this side is congruent to this side right here. And this side is congruent to this side right here. So we really have 3 triangles that share these congruent sides. There's a triangle right here that has those 2 sides. There's a triangle right here that has those same 2 sides. It has the 1 dash and the double dash. So they're just in a different order. And then we can see there's a triangle way over here that again has the single dash and the double dash. So we know that these third sides, AB, BC, and CD, they are their length would be based solely on that included angle. And so in this case, we realize that 46 degrees is smaller than 62 degrees, which is smaller than 72 degrees. So therefore, 46 relates to this side right here, CD. 62 relates to this side right here, AB. And 72 relates to this side right here, BC. So if we were to list those or order those from least to greatest, the shortest side of those three is CD, the next shortest is AB, and the longest side is BC. All right, hopefully that made some sense. I know the picture was a little bit odd, but hopefully that made some sense. Now, just like before, this is true both frontwards and backwards. Okay, and by that, what I mean is, see, I'm going to have a similar situation. Look at this picture right here. Here, we've got three triangles. Now, in the very first situation, at the very top, we said we could see that this angle was getting bigger. We went from 45 degrees to 75 degrees to 90 degrees. Okay, so now what we're doing is we're saying, what if we didn't know the angle? But we could very clearly see the side is getting bigger. It went from 12 to 16 to 20. Well, the same thing would be true because 12 is not as big as 16 and 16 is not as big as 20, then that would give us an understanding of the relationship of those angles. So if we were told to list the angles X, Y, and Z in order, let's say from least to greatest, well, then it would be very easy. We can see that the side 12 is smaller than 16, which is smaller than 20, and that 12 relates to X. So therefore, X is smaller than Y, because that relates to 16, which is smaller than Z. Okay? And so this works if we know information about the sides, then we can look at information about the angles. And if we know information about the angles, then we can figure out things about the sides. Okay, let me give you another example. Hopefully I can make this make sense. In this situation, which again is very similar, I am going to be asked to find the possible values or the range of possible values of X. And so in the same way, I would look at this and say, well, I can see that 12 is less than 16, which is less than 20. And in this situation, the 12 is related to that 48 degrees, which is less than 16, which is related to 3x, which is less than 20, which is related to that 87 degrees. And to solve this, I simply would divide all three by 3. And 48 divided by 3 is 16. 3x divided by 3 is just x. And 87 divided by 3 is 29. And so I don't know what the value of x is, but I do know that x has to be in between 16 and 29. It can't be 16 and it can't be 29, but it's got to be in between the two. All right? Now I'm going to ask you to do the same type of problem right now. Okay, so it is your turn. Now, it's a complicated looking picture at first, but all you have to do is focus in, find those two sides that you have information about. And in the same way that we did here, where I kind of looked at what did I know and how could I apply that, and then how could I solve it? I want you to do the same thing for this situation right here. This one's probably going to take just maybe a couple more minutes. I'm going to give you about 3 or 4 minutes to try this one. We'll pause the video, and then we'll come back and I'll work it through. So we can go ahead and pause the video right now. All right, hopefully you got it, or at least you have something. Now I know this was a more complicated picture because it almost looks like these are vertical angles right here, but they are not. I'm sorry if you were confused and you thought that they were, but they are not. Also, they are not vertical angles right here. That's a little bit more obvious. Okay, but what I see is I see that this side is the same length as this side. And this side is the same length as that side. So there's one set of triangles. Now, also, I see that this side right here is the same length as those other blue ones, and then this side right here is the same length as, let's see, there, those yellow ones are the same size. So look at what I know. I've got a 60-degree angle as the included angle. I have something I don't know what the angle is, And I have, well, it's 2x minus 4. And then I have a 36-degree angle, okay? Now the 60 is related to this 21. That's pretty big. This 2x minus 4, well, that's related to this 18, so that's not quite as big. And this 36 degrees, well, that's related to this 14, and that's clearly the smallest. So what I know is I could solve this a couple different ways, but how I would look at it is say, I know that 14 is less than 18, which is less than 21. And the 14 relates to the 36 degrees. So I say 36 degrees is less than, now the 18 relates to the 2x minus 4, which is less than the 21, which relates to 60. Now I have an algebraic inequality that I can solve. Hopefully you got to this point. All right. And so at this point, what do? Well, I've got to solve for x. And so I'm trying to get this x all by itself. So I'm first going to add 4 to all 3 parts. We've got what's called a compound inequality. It has 3 parts. Whatever you do to one, you got to do to all 3. So 36 plus 4 is 40 degrees. So less than 2x, which is less than 64 degrees. And then you just have to divide by 2. Divide this by 2, divide this by 2, and divide this by 2. And at that point, you get 40 degrees divided by 2 is 20, which is less than, or 20 degrees, which is less than x, which is less than 32 degrees. So again, I don't know how big x is, but I was asked, what are the possible values of x? And the possible values of x has to be in between 20 and 32 degrees. It is not 20 degrees and it's not 32, but it's got to be in between 20 and 32 degrees. All right, last problems. Here we go. I'm going to give you a 2-for-1. The last time you get your turn to try it, your turn number 4. I've got 2 illustrations here, and you're going to try these at the same time. Should probably take you about maybe 3, 4, maybe who knows, 5 minutes to do both of them. So again, we're going to pause the video right here, give you a shot to work on them, and then I'll work through them. Okay, let's take a look at this. I'm going to look at this first one, and I see that this side is the same length as this side, and that this side is the same length as this side. So I'm looking at that opposite side right here and right here. And I can see that 10 is less than 12, right? And that 10 relates to that 4x minus 18, and that 12 relates to that 54. All right. And so to solve this, I simply add 18 to both sides, and you get 4x is less than what, 72. If I add 18 right here and add 18 right here, these cancel each other out. And 54 plus 18 is 72. And so I have 4x is less than 72. I divide both sides by 4. And you get x is less than 18 degrees. So I don't know exactly how big x is, but to make this situation right here true, x has got to be less than 18 degrees. All right, very last problem. Now this one might have been a little bit tricky. This kind of reminds me of when we were doing proofs. These 2 triangles share a side. So that side is congruent to itself by the reflexive property. Hopefully you guys said that. And then we can see that this other side right here is congruent to this side right here. So again, we're looking at this included angle and this included angle and this opposite side and this opposite side. So I'm going to start this the way I've started all the other ones. Say, well, I know that 16 is less than 21. And 16 relates to that 32 degrees. And then 21 relates to that 3x plus 5. All right. So the very first thing I'm going to do is I'm going to subtract the 5 from both sides. So subtract 5. We get that 32 is less than 3x. And you divide both sides by 3. I'm sorry. Did you notice I just decided to skip and not do math right there? I'm sure you noticed that. 32 minus 5 is going to be 27 degrees. And so 27, we're going to divide both sides by 3. 27 divided by 3 is 9. Is less than 3x divided by 3 is x. So 9 degrees is less than x, or that could also be said x is greater than 9 degrees. So again, I don't know what x is, but I do know that x has got to be greater than 9 degrees. All right, I know that these problems are a little bit unusual, but there are some great examples in the book in case for some reason you didn't track with all of this. I am going to have this video posted, and hopefully you can watch it if you need to see it again. You guys can get started on the classwork, homework right now, and I will see you when I get back. Have a great day.